Hi, everybody. Is everybody awake? No? All right, fine. So, just to get some people warmed up, if you're a developer, can you stand up? Anybody's a developer in here? Come on, stand up, a few of you. All right, so we got a handful of developers. All right, developers, you guys sit down. All right, how many people are operations, administration, that side of the house? Stand up. Yeah, that's me too, so I'm already standing now. Cool, thank you. So, just curious. I'm largely going to be talking about the operations side of things for this talk. So, the talk is on hyperscale computing. It's kind of my perspective on things. Hopefully, it's a perspective that you guys will be able to learn something from. I'll be going into a decent amount of detail for how these large operations are run and what hyperscale computing is as well. So, I'm Nick Fury. If you don't know me, I've been doing this for a long time. I came to the very first CarolinaCon as staff. Came back the second year and spoke on robotics. I've done some other talks along a varied array of subjects. So if I happen to mention a company you work for or have friends that work for, please don't get upset and cry. I don't care. It's just how it is. So some of these companies that I talk about, I have my slant on this, so the way I view things. That's the only perspective I can really give you. So nobody's paying me to do this. I used to work for one of the companies I mentioned. It was a large depressed dinosaur. I no longer work for them. I work for a completely different company that has nothing to do whatsoever with cloud computing or hyperscale infrastructure at all, which is fantastic. So it's a hobby. I'm really good at it, though, I think. I think I've got a lot of interesting insights that other people don't have, and hopefully you guys will learn something from it. So basic outline, I've put some cat pictures throughout the presentation. They're all animated. Hopefully it'll keep you guys distracted if you do get bored with the topic. It's a little dense at times. So my plan is to educate and inform you. I'm going to talk about some key concepts. So talk about the players in the space. I'm also going to talk about the pretty pictures that come up. So, and I'm going to look at some attack vectors, potential areas of exploit for these large infrastructures. I'm also going to talk about the hardware and software side and potential vulnerabilities there as well. And then there's all kinds of crazy theories, so tinfoil hats if you have them. Why you should take this seriously. So the cloud isn't going away. And when I say the cloud, and by the way, you're more than welcome to turn this talk into a drinking game with the cloud every time it gets said. So hopefully your liver survives. It's not going away, right? This idea that somebody else has your data, the idea that somebody else is running your company's infrastructure, it's going to keep getting worse. So it's not going to get better. So anybody who thinks that they can put their security jacket on and go into meetings and go, I'm never going to let our company's data go anywhere other than here. It's not going to work for you. You will lose. And the reason you're going to lose is because it's becoming more and more expensive every day to run the infrastructure that your company has. So, and some of you might be working for companies where it's probably a drop in the bucket right now, and you probably don't see the power bill. Just wait. It's going to get worse. So as a species, we are using more energy every day than we did the previous day, and it keeps getting worse. It's not going to get better, okay? If you think that BYOD is just a trend, it's not. It's going to get worse. Again, other people own your data. Get used to it. So that's how this is going, all right? So the best thing I can tell you is to learn about what these guys are doing with their infrastructures and start questioning them about how they're running their operations, because that's as much control as you're going to have. So, yeah. By the way, the NSA's taking this seriously, so yet another reason to. So what is hyperscale computing? So it's a bit of a nebulous term. Basically, it's used in the industry to define very large data centers. I don't mean the, let's say, 2,000 to 3,000 square foot data center that most of you probably are familiar with. I don't mean the 16 servers sitting in a telco rack that shouldn't be there in the closet at your office. That's not it. A lot of this stuff can be applied to those smaller architectures, but it really doesn't come to fruition until you start applying it to much, much larger setups. So I will at some point talk about China and what they're doing, and you will understand the scale when I do that. So the scale is massive, though. It's huge. It's a scale-out architecture. It's designed for multiple processors, lots and lots and lots of them. So it's designed to distribute data across as many different servers as possible. It's redundant. It's highly scalable. It's geographically independent in some cases, so that if they happen to lose, so Amazon, for instance, with their stuff, they happen to lose a data center in Northern Virginia for some reason, magically the one in New York comes online or the one elsewhere comes online. So we're also going to talk about software-defined stuff. So this is kind of something that's been driving me crazy lately, is this software-defined everything. So VMware in particular is really bad about it and has hyped it up in all of their marketing recently. So their big thing, they bought Nicira, which is a software-defined networking company. They're trying to sell it. Cisco tried to get on board too, but jokingly said they were still doing hardware-defined networking, which is kind of funny. Cisco's they're about to lose a lot of money in the space they're in because they haven't kept up with what the industry's been demanding, which is cheaper shit. So in general, as consumers, we all want cheap stuff, so companies want the same thing. They don't want to pay for it. So software-defined, it's commodity hardware. It's cheap off-the-shelf stuff. It's things that are coming from ODMs in Taiwan. So companies like Wistron, Asus, there's a handful of them. So on top of that, they're putting open source software. So putting a distribution of Linux of some variety. And on top of that, they're implementing standards with APIs. So in the case of software-defined networking, a lot of it's based on OpenFlow, which is the latest and greatest project. So they're applying these open APIs to it. So they're documenting the APIs so that the APIs are what gets called by the code that everybody's writing for these things. So the OSI model, everybody knows, right? 7 layers. Anybody know them? I have no prizes to give away, so if anybody wants to call them out. So, by the way, you're more than welcome to interrupt me at any point during this if you guys have questions. So, but the bottom line is the OSI model is getting a lot more complex. Granted, the model still applies. I'm not telling you that it's changing. What I'm telling you is that each one of those layers is getting lots and lots of its own little sub-layers, okay? And it's just getting worse. So, it's not necessarily bad. Yes? That's part of what I'm getting at with, I'll talk about that when I get to the attack vectors, but that's definitely, you're going in the right direction, I believe. So you're gonna see that as this stuff becomes more complex, you're gonna see vulnerabilities like heartbleed multiply. So, and what's really irritating, I think, is that you're not gonna know about it, because as a consumer of these technologies, somebody who uses Gmail or whatever you happen to use, DuckDuckGo, doesn't matter, you're not gonna see this. The guys who are running the back-end infrastructure, they're the ones who have to go in and clean up this mess, and they're probably not even aware of it to begin with. So, and it's just gonna get worse. So the story of hyperscale computing is really the story of Intel. So back in the day, right, Intel made RAM chips, okay? They made them for a bunch of different manufacturers for large mainframes, essentially. So DEC, IBM, all those guys, right? So Intel comes along, though, with this magical x86, actually at the time it wasn't, but they came along and started manufacturing processors, right? So they start manufacturing these things, they start going into home personal computers. Linux comes along, Torvalds comes out with Linux, right? He writes it so that these guys who are banging on Unix and System 5 stuff all day long can go home, and all of a sudden they're able to take their work home with them and start hacking on it at home, on their home personal machine, okay, using Linux. What's happened over the last really 20 years is that it's come full circle. We're now taking those technologies that we've all been taking home and we're bringing them back into the workplace. So x86 is now the dominant force, okay? Intel's outlived DEC. They've outlived IBM, which has pretty much sold off everything wholesale to Lenovo at this point. And they've outlived a handful of other companies as well. So Cray, et cetera. So these companies that used to make mainframes don't make them anymore. Sun's pretty much dead at this point. There's probably a handful of you that have to deal with Spark. I'm really sorry. If you do, it's pretty much dead though. Like Sun's losing customers, Oracle is. So for Spark anyway, they've ported everything to x86. They're starting to embrace VMware finally, despite the fact that Oracle has the most nonsensical licensing requirements that I think I've ever seen. So yeah, the story of hyperscale computing is really the story of Intel. So it's this rise to dominance with it. So on that note, the largest customers for these guys are companies that we've heard of. So what I'm going to do is play a little game. Again, I have no prizes to give away other than some cricket suckers left up here from the previous talk probably. So I'm going to put up a slide. If you guys can tell me, somebody wants to raise a hand and tell me or blurt it out, I don't care. What company this is. So here's the first one. It's an easy one. Anybody? No. Google. So, right? So this is Google's latest and greatest data center. What you're going to notice in these pictures is there's a unique, particularly with Google, with this one. This one's a couple of generations behind now. My guess is probably about 3 where they are currently. What you're going to notice, though, is there's a lack of fancy black panels covering hard drives and systems. There's a distinct lack of wiring for the most part, though there's a little bit. So Google, as a company, is all about something called PUE for their data centers. So PUE is power usage effectiveness. What they're trying to do is get this down to a ratio of 1, which is the ideal, fantastic ratio. They're probably right now, if I had to guess, at a ratio of maybe 1.2, 1.3. What that means is PUE is a ratio of how much of the energy that goes into a data center is used for the actual IT work versus how much of the energy is used for things like power and cooling and keeping admins alive and whatever else needs to be run in this data center, okay? Google is super, super secret with their data center designs. So they were the first company that I know of to have production-grade software-defined networks. They've been running their data centers on it for a long time now. You would never know this. You're not supposed to know this. This is all back-end stuff, right? They do a very good job of hiding these things. They're one of Intel's largest customers. So the latest and greatest from Intel, if you guys aren't familiar with the semiconductor manufacturing process, the way this works is Intel turns out chips, okay, nonstop. So they make them on wafers. They do something called binning. What that is they take the chips that are on there, and based on the quantities that they need, they will in turn take certain chips off based on the features that are available to them. So in the case of some dies, some of the cores don't work. So all of a sudden, if you've got one core that doesn't work on a 6-core chip, they can take 1 or 2 of them off and defuse them or fuse them so they're closed, and magically it's a 4-core chip, right? And turn around and sell it. So if they couldn't do that, then they'd be stuck with a funky 5-core chip and they wouldn't be able to sell it for anything. They don't do that though, they're smarter than that. So the latest and greatest from Intel, there's a very good chance that companies like Google are telling Intel what instructions to put on these CPUs. I, as a data center admin, don't know what the hell is on my chip anymore, okay? And it's really hard to find out a lot of this. So a lot of it's behind NDAs that Intel will make people sign, and even then, I'm not entirely certain that I believe everything is there. And this whole shit with the NSA recently makes me question things even more, because if they've got guys working at Google, there's a damn good chance they've got guys working at Intel. So I would. So yeah, Google, one of the great things with them, you can find out lots of information about them just by looking at what contributors are submitting code to a lot of the open source projects that are out there. So it's a great way to find out how to pull information back. So Lisa did the talk on metadata yesterday, and one of the cool things that I found is you can actually go look at the metadata for a lot of the open source projects that exist. And you can actually look at where the contributors are coming from, which countries they're submitting code from, which companies they're representing, which ones are listed as personal, and then you can go reverse engineer it from there if you want into more and more detailed information. So Google does a lot of white papers. You kind of have to know where to look for them. You have to know the names of the people doing the research to actually go find out what they're doing. So, all right, next one. No. Facebook. So Facebook has started something called the Open Compute Project. So the story for Facebook is really all about the Open Compute Initiative. Basically, Facebook realized they were getting creamed by Google in this space, and they weren't doing enough research for it. So instead of trying to buy into it, which is typically their response to most things, they went out and actually founded this initiative called the Open Compute Project. Open Compute is a set of hardware specifications, it's a set of standards that they're using to build newer and newer generations of equipment. So it's basically, for the first iteration of this, they created an Intel-based motherboard and an AMD-based motherboard, defined some stuff on the back of it so you could actually literally just slot it into a rack and power the thing on, and away you went, instant compute, right? It's getting more and more complex as the time goes on. They're starting to define more standards with it. They've defined standards for storage. They're defining standards for networking. They're defining standards for interconnects too, which I'll get to later. So I have a feeling that before too long, you're going to see the open source specifications for a floor tile that'll funnel air further up. So if you guys are not super familiar with data centers, typically you have a hollow floor that you're standing on top of. It's anywhere from 1 foot above the ground to 3 or 5 feet in some instances. It's funneling air underneath. It's going up in front of the servers. The servers are sucking the cold air in on the front side. It's going out the back as exhaust. It's hot. Hot air rises, right? So you have stuff in the ceiling, which in turn takes it and funnels it back into the floor, okay? Kind of crazy how this is working. So Facebook's gotten really good at this. They've done this Open Compute Project. It's kind of cool. I appreciate the fact that they've done the open source thing with it. I do question if it's entirely the right direction to go, but I'm glad that I can at least go find out information about where they're at with their designs. And I know that Facebook in their data centers isn't too far ahead of what the latest and greatest debates are on the Open Compute Project forums. So let's talk about China. So I've got Chairman Mao clapping. So China, being China, stole the Open Compute Project from Facebook, and I mean literally stole the whole damn thing, and rebranded it as Project Scorpio. The only thing that they really added, which is very, very interesting to me, and hopefully there's a laser pointer here. Is this bit? Maybe. I lied. There we go. So, can anybody read that? It says asset positioning and management with GPS. Okay, China's data centers are so large that a guy with a flashlight and a map can't find the damn server anymore. They can't just go turn a little blue light on to go find out where it is. Okay, if you're familiar with servers and the management concept, there's the little blue information light on most of them, right? So there's a little setting in the management tool, the IMM, the iDRAC, the ILO, whatever the fuck they want to call it. IPMI. Well, IPMI is actually the standard for interfacing to it. So IPMI is a bigger industry-wide thing. All the different companies have a web-based GUI of some sort for these things that actually talks to the server via IPMI, at least as I understand it. So yes, China took Open Compute. They said, this is great, let's add more. And so what did they add? They added a GPS chip to every one of the servers. So think about that for a second. This is a data center so large that to find a server, you need GPS, okay? Kind of mind-blowing, right? Yeah. There's also, I have a feeling, this is just some slide from some random ass slide deck I pulled offline, and I believe it's legitimate as far as I know. This is, if you go poke around and actually try and find information about this Scorpio stuff, it's really difficult to find. Not the least of which I don't speak Mandarin, so yeah. Anyway, bottom line being GPS is a method of doing this. You can actually do it within a data center just by triangulating signals. So anybody who's super into radios can tell you all about how to do that and how you can locate somebody. So Mitnick comes to mind. That's how they found him in Raleigh when they caught him. So same basic idea. All right, so another one. No, not IBM. I don't have any pictures of IBM, oddly enough. So you'd think I would, but anybody? Not Amazon. We'll talk about Amazon though. Twitter, nope. Who else? One more. Somebody. Not Microsoft. Nope. Walmart uses IBM, so it would be a picture of a bunch of random black boxes. So, nope. Rackspace. Ooh, we've all heard of them. Yes. So the story of Rackspace is really the story of OpenStack, right? So how many people work with OpenStack? Anybody? Couple? All right, cool. So hopefully you guys are contributors. It's a fantastic project. It's got some interesting implications if it actually ever manages to go anywhere. The contributors to these projects are familiar names. It's Dell, it's HP, it's IBM, it's anybody you can imagine. Rackspace got into it because they were hosting, as far as I understand it, NASA's stuff. NASA was doing this. NASA has abandoned ship and flown the coop to Amazon now, which is a common story, oddly enough. So OpenStack's kind of an alternative to VMware and Hyper-V, but not really. It's not a hypervisor. It's more. It's a lot more than that. It's sort of a management setup for hypervisors. But it's more than that, too, because it's a management setup for software-defined things. So it's kind of nebulous, which is funny because part of it's, anyway. It's out there. So it's very complex. I will tell you that if you have not taken the opportunity to go look up OpenStack previously, go do that. It's a big thing. It's going to continue to be a big thing right now until companies realize that hosting their own shit is really expensive and they should pay somebody else to do it, which they're starting to. It was designed for massively large deployments. So it's based around open source APIs, and in particular, it's compatible with other APIs. The latest and greatest from Rackspace is that they're looking to either partner or be bought out. I don't know how that's going to go yet. If I were to guess, I'd say that HP or Dell's a potential person to buy them out, potential companies to buy them out. If IBM had any brains at all at the C level, then maybe they would, but they don't. So yeah, so that leads me to these guys. Anybody? And this is blurry as hell. And if you can't, Amazon. So the reason it's blurry as hell is because finding out anything about what these guys are doing has been extraordinarily difficult. Amazon is, like, everybody thinks Apple's really good at keeping secrets. No. I promise you, from a data center perspective, it's much easier to find stuff on Apple than it is on Amazon. So everybody else in this space is playing catch up to these guys. Amazon did this first, okay? This is a company that sold books. They beat IBM, a company that has been doing computers since the dawn of time, okay? If you guys didn't see the CIA lawsuit that happened, right? So CIA said, we need some computing resources. IBM stepped up to the plate and said, yeah, we got that. We do government contracts, no problem. Amazon also stepped up and said, they'll be willing to help you out. IBM lost. IBM threw a hissy fit, okay? They got their butts kicked in court and went crying and said, Amazon cheated. Amazon didn't cheat. It was ruled that they didn't, okay? It's a little bit more complex than that, but the bottom line is Amazon ended up winning the contract. Amazon's now running the CIA's data center, okay? Using their infrastructure and technology. So it's really, really, really difficult to find information about these guys. I tried. So one of the ways that I've learned to find information about this stuff is not by looking for direct sources of information, but by looking at indirect sources of information. One of the most telling is job postings and HR people who are more than happy to interview just about anybody, as it turns out. And so if you talk to these guys, particularly the HR people, and mention certain technologies and things they know to look for, they'll respond accordingly, okay? Do you guys use X? Oh yeah, I've got that on my list. I see. When you start getting past the first level of HR and into the management level and into the folks who actually run things, they'll give you even more information. So it's a great way to find out information about what companies are running for infrastructure, as it turns out. Yeah. Go apply for a job. Hell, you might get one in the process. So, I mean, it's crazy as it sounds, like, it's what to do. So again, this is a hobby for me more than anything else, but it's very interesting to me the fact that they're willing to give away so much to people who are potential candidates for their company. I don't know that they realize how much they give away. So, and I'm not saying they give away, they're not going to give you the root password because you're interviewing. No, okay? They're going to give you information that they would not normally be willing to share. These companies don't publish with other companies. So very common in industry is for EMC to offer a discount to some company because they wrote up a fantastic review in a white paper about how they're using EMC's latest and greatest storage product, whatever it is, right? You don't see that with Amazon. Amazon's not running EMC's garbage. Amazon's running their own storage architecture. So you have to ask questions about what it is and where they got it from. Amazon's not a storage company. They're not a company that sits around and makes hard drives, right? They're sitting around paying guys to figure out what the latest and greatest open source technology is that they can go borrow and then start contributing to that code base. So again, another way to find out information about this. So Amazon has APIs for just about everything. As far as I know, they were the first on the scene with GPU, so general purpose graphics processing stuff. They're basically using NVIDIA cards and allowing you access to them. They have APIs into it, so you can spin up an instance, and voila, you can do whatever password cracking you need to. It sounded like they've actually got instances specifically for that now, which is really cool to me. Amazon's had APIs for this stuff from the get-go. They're built around it, which is really, really impressive when you consider the fact that VMware just came out with their VCHS, the VMware Hybrid Cloud, or VHCS, Hybrid Cloud Solution, something like that. Basically, VMware's playing catch up to these guys, and they've created a cloud environment that doesn't have APIs yet. Oops. Yeah, it's silly. Like, I want to be able to make a REST call and create a VM instantly. I don't want to have to sit here and click buttons for 20 minutes. That's not what that's pointless. It's very bad. So initially, Amazon was based off of Zen. They've kind of moved on from there, I think. I don't know 100%. I know that they still use it, but I think they've moved on beyond that. So they have lots and lots of different services. If you need Hadoop, if you need database stuff, they've got Redshift now, and they've got accelerated databases. The coolest thing that I've seen them do, by far, was they said that this is how much it costs to run an hour of CPU time. So one processor equals this much money, so 7 cents or whatever an hour, okay? Then they said, well, you've committed to having that CPU, but you're not using all of it. So what we're gonna do is we're gonna offer a reduced rate for somebody who wants to come in and use the CPU that you're not using. So in other words, they're taking the leftover bit that you're wasting because you're not using it. They're charging you for the first bit, even though you're not using it. They're going, you're not using this. I'm going to schedule a lower priority task in that same spot and charge them money too. I'm going to charge them less, but I'm going to charge them money too. So they're making money off of the waste. How fucking brilliant is that? So they're Intel's largest customer by far. So their data center keeps growing and growing and growing, and they keep adding more of them, largely because of Netflix and the fact that all of us binge watch TV shows like you wouldn't believe. Netflix is one of their biggest customers. So the Fortune 500 companies are all starting to flock to them because they're realizing that IBM and HP and Dell don't have stuff in this space. So they're going to these guys. So the best part is I can take a credit card out of my pocket without any special fancy PO numbers or trying to pretend to be a company and having a tax ID. Take the credit card, go online, in the same place I can get toilet paper subscribed to, I can get a fucking server, okay? That's really cool. So, the others, IBM. IBM is SoftLayer. They don't have anything else. They kind of just bought their way into this not that long ago. SoftLayer's not a joke, but at least not a very good one. But they're not that big either. So I don't know that they're going to grow to be that big. They've now got IBM's brand name behind them, and I'm sure somebody who's playing golf with some exec is more than happy to sign up for the services. But yeah, no. IBM has also sold off everything to Lenovo, and if you go look online, there are pictures of SoftLayer's data centers. They don't use Lenovo equipment, okay? Everybody who's doing this and doing it seriously is not using equipment from OEMs, from companies like Dell, from companies like HP and IBM, Lenovo, whoever. They're not buying servers like that anymore. They're buying servers by literally the crateful from places in Taiwan, okay? They're going overseas. They're saying, hey, would you mind taking this Intel chip that we've got, that we've worked out with Intel that you're going to put into the server for us, and just using their standard specifications and creating a motherboard and putting it on here and sending it back to us so that it fits in our racks. That's all they want, okay? Server gets there, they boot it up into however they're booting it up. Most of the time it's Pixie now, and they're running things off the network. I think a handful might be using Flash locally on the systems and attaching that to the motherboards, but I doubt it. I don't know why you need a local OS. So, but anyway, that's what these guys are doing. So Microsoft is there. Microsoft is Azure. Unless you're running Exchange or Office, I don't know why you'd use them. I guess if you wanted to put your domain controller out on the web. And you can laugh, but this is what people will do. So they're starting to do SSO stuff. Anybody played with the SSO stuff for Microsoft at all? So it's interesting. Microsoft is pushing that into Azure as well. So Apple's a little interesting. There's a lot of speculation that they actually might be using Amazon, and they might be using Azure and a handful of other services. I can for certain tell you they use Akamai for damn near everything. So anybody ever looked at traffic from iTunes? Wireshark, yeah, bounces off of Akamai, goes all over the damn place. So Apple built some fancy data centers, 2 of them, one of them in North Carolina in particular. They've built these data centers, but the speculation is that they're probably not really using them. There have been, after it was built, basically the time period when you would expect to see trucks full of equipment rolling in, nobody's seen any trucks rolling in. So handful here and there, and it's possible they're just still building it out, and there's some service that's coming that they need, whatever the new iWidget is that they need to offer some service for. But as of right now, nobody's reported a large amount of trucks moving equipment in and out of this thing. So I don't know what to tell you. Do what? Lenore, there we go. So I can't tell you the square footage of the data center. I'd love to be able to. I can't tell you exactly how big any of this stuff is. It's really hard to find this information, as it turns out. They don't want this stuff getting out. So it affects their numbers. So Amazon, by the way, very interesting thing, Amazon doesn't report the exact amount of money for how much they make off of EC2. So they put it in the other column. So when they report their revenue numbers, okay, because they have to, their quarterly numbers, they go in and report them and they say, we made this much money. And they break it out based on services. So their retail industry and then some other things. And then they have this column called other. And mysteriously, that other column keeps getting bigger and bigger and bigger. And we all know what it is. Like, everybody knows that's, like, everybody's really interested in it too now, because it turns out they've done this really well and people are starting to pay attention. So, but yeah, it's listed as other. Same thing with Microsoft. I don't know that they report exactly how much revenue they're generating off of this. So, not big. It's not massive right now. So everybody who's doing this and is serious about it is moving to Amazon. So I'm not saying that that's the right answer. I'm just telling you that's what the industry is doing. So yes. Sure. It does. It's using their services on the back end, so I don't know enough about their special nonsense. So my counterpoint to that would be the PlayStation 4 has massively outsold the Xbox One right now and continues to. So I don't know that the demand is there for Microsoft services yet. If they can get the problem they have, and the problem everybody's got with this space, everybody's trying to play catch up to Amazon, right? So go read the news stories. In fact, I'll tell you exactly what you can search for in Google News. Go look for Amazon EC2, and then the word price reduction. Over the last year, Amazon has reduced prices probably 6 times, and they keep doing it. And the reason they're able to do this is because they keep buying more and more shit and reducing the cost of what it takes for one individual instance to run. So the more times you can do that, the more scale you can add, the better you're able to take advantage of the economy of scale, okay? Where you can go, you know what, we've got 50 billion of these, one of them doesn't cost that much, so they can reduce the cost. Everybody else is playing catch up to this because they can't get to that price point. So they need to go way out of their way and do what Google is doing via the PUE thing, trying to figure out how you can get every last possible energy wasting mechanism out of your data center and fix it so that you don't have any energy that's wasted. Everything that you have in your data center is going to IT-related functions. So it's going to your overall mission. Google is actually trying to do this, and they're doing pretty well with their compute engine, or what is it? I think it's compute engine, something like that. So, yeah, they do. It's compute engine. Is it compute engine? I thought it was the name. Sorry. So there's so many of these names now, they all get sort of cloudy in my brain. Haha. So yeah, I can tell you for certain Apple does use a lot of NetApp. They have a habit of hiring former IBM employees, and they seem to have some interesting cloud stack based on code contributions. Yeah. Fair enough. And so the Google data center here, the one in North Carolina, I think is probably a generation behind the latest and greatest from Google, if I had to guess. So it hasn't seen any updates recently that I'm aware of. Yeah, if you guys want, so this information, I think one of the more interesting facts, you can find out lots and lots of stuff about this just by knowing sort of the area and location around the data center and what they're doing. So the local news and local commentary from people in those areas is always good. Yes? Yeah. Yep. Yep. Oh, wow. Yeah. Yeah. Yep. They don't like to talk about this stuff, so it's really, really hard to find out about it. So yeah, Apple also, they run a lot of custom stuff, and they're really smart, and they're super secret. The people who work for them are all fairly brilliant when it comes to doing these things. They're submitting code and patches to very low-level applications. So their submissions turn up in a lot of the work that goes into the Pixie stack, so Pixie Linux. It's shown up in some other interesting locations too. So let's talk about the NSA and all of this. Yes, they can hear you now. Yes. Don't worry about backups. I got you covered. So they know why kids love Cinnamon Toast Crunch. They have the share everything plan. They're watching you poop. Edward Snowden might be too. I don't know. They are actually listening to you. They care. Now, so the NSA is involved in this somehow. I don't know. It has not come to light yet. So the latest and greatest that I've seen was the news that came out earlier this week about the Cisco switches, routers. Basically, they have a location where these guys from the NSA will hijack a Cisco router on its way to some foreign country. They take the Cisco router out of the Cisco factory sealed box, figured out how to cleverly open it and put a new Cisco label on it, right? Because I'm sure Cisco's not giving them those. And then put some custom stuff on there and then turn it back to them. If they can do this, then I'm just going to go ahead and guess that they probably have people at places like Intel. I'm willing to bet that they probably have places at some of the ODMs in Taiwan. And I'm willing to bet that they're getting involved at a lower level than what we know. So the stuff we know about is what's come to light so far. I guarantee you there's stuff we don't know about, and it's kind of creepy. On that note, I'm still using Gmail for my email. Sorry, Lisa, I can't give it up. It's too hard.
I wonder if
So.
the NSA dollars could take out the Chinese spy.
I don't know. Well, that's an interest. So
Or there's like a port right next to the Chinese chipset that they just...
they just plug in like foreign local manufacturing spy chip here, foreign national here. Like, yeah, I don't know. I know that I don't know what China is doing either. So China.
They would put it in the gray market stuff.
They were talking about, China's also been talking about fracturing off from the US for a long time and creating their own CPUs and all this other nonsense. They've yet to do it. Kinda. CPUs are made worldwide now. So the shit that happened everybody remember a couple years ago, hard drive prices went through the roof? So yeah, that's because of flooding in one part of the world. Yeah, so that's where all the hard drives are made. Guess what Intel realized a long time ago, right? Intel had some smart people working for the C-level, right? And we're like, you know what? We should really split up our operations across the world. So they did. So chips don't come from one spot anymore. They come from all over. So yeah. No. So I'm going to talk about attack vectors. So I'm with you definitely. The Cisco stuff's not new. Again, to me, in my mind, it's what the hell are these guys actually doing? Because this is just the stuff we know of. So attack vectors. If I were looking to break into a data center and looking to get involved with these things, I would start looking at the developers. I'd start looking at where the code contributions are going, and I'd try and insert stuff that might be slightly nefarious into those sources. So GitHub's a fairly open place. There's all kinds of interesting projects that are going on, and figuring out who's submitting code to them, not that difficult. I will tell you, Apple very, very cleverly doesn't allow their employees to submit code under the Apple, very rarely anyway, do they allow their employees to submit code under the Apple, with their Apple email addresses. So they use other email addresses to submit stuff. So finding those employees is difficult. Finding their contributions is also difficult. So LinkedIn, though, turns out. Anyway, you can also attack the control plane, which is where really the inserting code comes from. So a lot of these environments have sort of two levels. So there's the level where all of the data actually is, and then there's the control plane level. So particularly with software-defined networking, there's definitely a control plane. You have to. You can't avoid it. If you look at that area, I think that is going to be the most vulnerable spot where you can insert potential vulnerabilities, where you can look for potential vulnerabilities. Attacking the hardware, again, goes back to what I was talking about with the NSA, attack the developers. I guarantee you, does anybody in this room read the Intel CPU erratas that come out? I sure as fuck don't. So yeah, the CPU erratas that come out, Theo Durant likes to bitch about them. If you guys know who he is, does anybody know who he is? No. Theo's the head guy for one of the BSD distributions. I can't remember which one, Net or Free or whichever one. OpenBSD? Yeah, there we go. The one I didn't name, so. Yeah, so Theo likes to complain about it. He's made a couple of very, very public posts shaming Intel. Intel still makes crappy products that have security vulnerabilities. You want to know how to attack something? Look at the fucking CPU. Gee. So yeah, I can't tell you what all the instructions are on a CPU these days. There's so many, and the instruction sets keep they're added to bit by bit. So the same thing with RAM in the machines. If you have systems that have more RAM than they should probably have because they're not based on an Intel reference design, then you've got ASICs probably. Chances are you have ASICs anyway. ASICs are chips that are manufactured for companies like HP, Dell to put into these systems. They're custom chips. So they allow the system to do something unique and interesting and fundamentally different than the other guy. Not really. So, well, ECC is the memory checking for RAM. So. Yes, you do. It's not an ASIC though because there's enough manufacturer. I mean, I guess it kind of is. I don't know. I don't know where you draw the line between. I'm sure there's some technical explanation for where you draw the line between an ASIC and a normal chip IC, but it's, to me, again, ECCs. There's so many of them, but it's a great spot to start looking for vulnerabilities potentially. So the controllers for any of this stuff, I'd start looking for vulnerabilities there. So. Yep. Yeah. Potentially, the Open Compute project, they're using open source firmware. The open source firmware movement never really picked up that I know of, so there's not really an open source BIOS implementation that all the vendors are using. But that being said, the BIOS, the firmware, most of it comes from the same ODMs in Taiwan, so yeah, I'd potentially go look there and try and figure out vulnerabilities. If Daryl was here, I'm sure he'd back me up on that and say that that's probably a fairly vulnerable spot. I know he's done a little bit of research into those things, so yes. Okay. Yeah, AMI. I know American Megatrends does a lot of that stuff. I know they pop up all over the place, so the research that I've done, I don't know, I'd be curious to see how many vulnerabilities they publish or if they publish anything at all or if anybody publishes stuff for them, so I don't know if they do. So one more attack vector is the data itself. So all of these hyperscale infrastructures are based around the idea that there's a massive data set that they're crunching, so there's lots and lots of numbers. So you can poison the data set. So it's fast and can be fairly effective. Yeah, I know, I've got 5 minutes left too, so. I have my own clock. So yeah, consumer surveys, medical trials, voting data, as more and more of this shit gets put out there, expect it. I mean, I think people are gonna start looking at the data because it's easy, rather than trying to attack the actual underlying infrastructure. So I suspect that's going to get more and more complex to do, and the skill set for doing it's gonna become more and more specialized. So as for preventing attacks, if you happen to work for one of these companies, so things I will tell you, hard outer shell with a soft squishy center doesn't work anymore, okay? No. So you have to protect everything. All points of communication must be secured. So I don't know that that necessarily means SSL anymore. I'd be very curious to see what's coming along soon to potentially replace SSL so that there's a better form of secure communication. So, and I suspect these guys are working on this for their data centers. So you need to verify the data. You've got to control all your control points such that they're redundant and they're independent of geography. So they're geo-separated so that if one site gets hit, you've still got something to come up in another site somewhere. So the future, where things are going, it's just going to get more dense. So more CPUs are going to get crammed into a smaller and smaller space. So Google's going to continue pushing PUE to 1.0, I suspect. If they aren't already at it, I don't think they are. I think they're very, very close, though. You're going to start to see more CPU types. ARM has now come up. Lots and lots of people who are doing development for phones, and they know ARM. They don't necessarily fully understand it, but they know ARM. It's also come about that you need to have ARM CPUs available in the cloud so that people can magically create developer instances out in the cloud, right? So, yeah, Itanium, there you go, the Itanic. Yeah, thank God they finally killed that off. Anyway, it's going to be easily switchable between CPU types, between RAM types, and I'm going to get to that in just a second. Things are going to be interchangeable. So you're going to start to see software that's based around, so particularly the control plane software is going to start to do what Google's been doing with ads and continues to do with YouTube videos. Google has machine vision processing that they've created that literally just goes and crawls YouTube for videos and descriptions and comments, and it proceeds to compile all that data, and they don't understand how this works. They just know that it works, and they use it with Google Translate as well. So basically, every time you go to a site with Google Translate, it's getting better and better at translating that data. So it's a new site potentially, or it's new data, and you can opt to select things and correct them or not, or whatever. Every time you do that, you're giving them more information. So they keep building this database of patterns. They don't know how this works, okay? I'm not joking, like nobody, like they understand there's a pattern, right? But the pattern is generated by a computer. We don't understand what the pattern is. So it's just getting smarter and smarter. I'm not telling you that Skynet's coming. Maybe it is, I have no idea. But what I'm telling you is that this is going to get applied to software-defined networks, and it's going to be applied so that if traffic needs to go somewhere, it's going to go there based on the fact that it's seen that sort of traffic 17 billion times before, and so therefore it knows what to do with it. So the learning patterns are going to be applied to these setups. Same thing for virtualization or virtualized workloads and everything else. So you're going to see this stuff get smarter and smarter all on its own, which is kind of cool. So, Intel has this fantastic thing they're calling the disaggregated rack, which is a cool term, I thought. So basically, they're going back to blades. And if anybody's ever done work on Blade Center stuff, you typically have a box that's like, I don't know, 9U, 11U high in a rack, right? Imagine if you had a 42U rack filled with these things, and instead of like blades that have enclosures made of metal and everything else, you just had a circuit board. Okay, that's what they're building. The back end, you're starting to see fabrics converge. They're converging around PCIe as the fancy standard. So it's basically they're taking all the work that the InfiniBand group has been doing, and they're basically moving it one level lower to the PCIe level. It makes it so that you only have one switch at the top of the rack that gets plugged in. So you bring in a rack load of stuff at a time. So there's more of this. So Intel's doing a lot of work for optics right now, so I'll talk about this in a sec. These guys right now, they're talking about microservers particularly. I don't know why, it's pointless. A microserver is just a server, but right now, because they've just started doing this, they're just really tiny, and they can't figure out how to cram enough RAM into this thing to make it useful. So they're selling them to companies who think they need lots and lots of little tiny servers, and I guess maybe some people do for their workloads. I don't know. Yeah, anyway. That's a tiny, it's one computer. At this scale, it's a little different, in my opinion. Yeah, so Intel's starting to sell these things, they're starting to develop it right now. AMD is actually the one that's selling the microserver. They bought a company called C-Micro, primarily for their technology with interconnects, so which that's the next big area of research. So right now, interconnects between stuff, it's slow, it's error prone. Anybody who's had to deal with cleaning fiber optic cabling, it's a pain in the ass, right? So I hope somebody has. I'm not alone in that regard. So Intel has literally redefined what a fiber optic cable is. That thing's got, I don't know, 64 or 128 fiber connections inside of it, and they're starting to use it to transfer PCIe over large distances. Yeah, I think my time is up, so. The blank sign, I don't know what was on that one. So yeah, it's continuing to grow. Interconnects are by far the most interesting thing, I think, right now. So microservers, there's lots and lots of tiny servers putting on chips. Calxeda was a company that was doing this with ARM. They've gone bust now. I don't know if they actually managed to sell off all their assets to somebody or not. They had a lot of interesting intellectual property. I don't know that they sold it off. The biggest problem they faced was that ARM isn't 64-bit today. I mean, it kind of is. Nobody's got a real 64-bit ARM chip out. They're coming. They'll be out within the next 6 months, but that was by far Calxeda's biggest problem. So AMD, C-Micro again, so they've started to produce ARM chips too, which is kind of cool. So, and that's it. So I'm going to end with Arthur C. Clarke and his any sufficiently advanced technology is indistinguishable from magic. So if you don't know how this shit works and you think the cloud is magic, it's not. They're just using the same stuff you use at home and applying it at a much, much larger scale, right? So there you go. That's it. Thank you.